Ellipses. The formula for ellipses has a plus in the middle. Has a plus in the middle. They're both equal to 1, but it has a plus. The formula for hyperbolas has a what? Has a minus in the middle. So that's one way to tell the difference. One has a minus, one has a plus. A is always bigger than B in an ellipse. In a hyperbola, anybody know?
B is bigger than A?
No relation whatsoever. So B can be bigger than A, smaller than A, or even equal to A. Okay? The next thing is that in an ellipse, A squared minus B squared equals C squared. In a hyperbola, anybody have any idea?
A squared plus.
Very good. The way I remember it is the guy with a minus in the equation has a plus in the Pythagorean theorem, and the guy with a plus in the equation has a minus in that one to find C. The shape of an ellipse is an oval. The shape of a hyperbola is if an ellipse was cut in half, and you know how magnets reject each other, and they both had some magnetic field that are facing them in the other direction. These can be vertical or horizontal, but it's a totally different shape. It's a totally different graphing situation. So you put the positive term first. In this case, the positive squared term is a y, so the y's go first. Because if you look at your hyperbola formula sheet, here you go, if the y's are positive, it's vertical, and if the x's are positive, it's horizontal. So it's important to know who's positive and who's negative, okay? So before you can complete the square, you've got to pull out that 6. So that's minus 6y plus 9, and then minus 4 parentheses x squared minus plus 2x plus 1 equals negative 26. And then what did I really add to the first parentheses?
9.
Nuh-uh. I added 54.
Oh, 6 times 9.
And what did I add to the second parenthesis? Very good.
How'd you get the 50?
Now I'm going to factor. I have 6 y minus 3 squared minus 4 x plus 1 squared equals 24. And we know that this equation is also equal to 1 like the ellipse, so we divide everything by 24. And we get y minus 3 squared over 4 minus x plus 1 squared over 6 equals 1. Okay, the first thing, just like everything else, we have an A, B, C, H, and K. So let's go around. Somebody tell me one of the letters you know is for sure.
H is 2.
H is 2.
Wait, wouldn't it be 3?
No.
H is not 2. H is not 3.
Oh, I mean, no.
Negative.
I mean, H is negative 3.
Negative 3.
K is 2.
K is 2. Somebody else. What about A, B, or C? Look at your formula sheets and tell me what A is. A is always the guy under, A squared is always the guy under the positive term. So if 4 is A squared, A is 2. And what is B?
3.
3. And now we find C with 2 squared plus 3 squared equals C squared. 4 and 9 is the square root of 13. Got it? We're going to build a box. Is this hyperbola vertical or horizontal?
It's vertical.
It is vertical because the y squared was positive. Yes. So it's vertical. We know it's vertical. I always put like, remember that? So now that means that A goes up and down. So the first thing we're going to do is graph the center. Negative 3, 2. And A is up and down because it's vertical. So we're going to go up 2 and down 2 and draw a little dot. And B is 3. So we're going to go right 3 and left 3 and draw a little dot. And now we're going to draw a box around those dots. So we're going to go over here. Let me change this color. Come down and make our box. The box can be any shape. It's going to be a rectangular or a square, but it can be anything. It can be facing up. It can be facing down. The A goes with the major axis, with the direction of the hyperbola, and the B goes in the other direction, okay? This is kind of complicated. So now we're going to take a ruler, and I'm not going to do that, so it's going to look ugly, and I'm going to connect the corners of the box with a line, and go through the center if you can. So I'm going to draw those. Those are the asymptotes. You don't have to really come up with the equation. Just once you build your box, you go through the center. And since this is vertical, you're going to go from this point here, and you're going to draw a parabola facing up and hugging those asymptotes, and a parabola facing down and hugging those asymptotes. Now all we have to do is find the foci. So what is the formula of the focus on a vertical hyperbola? So the foci, we're going to graph them. It's negative 3, negative 1.6, and negative 3, 5.6. When we graph them, they're inside the parabolas. So that means they're a reasonable place for the foci.